Hello everyone, my name is Luis and today I'm going to presentate about my embedded system final projects. And for our embedded system, we use Intel FPGA DE10 standard board. Okay, let's just go into it. So what is my goals or what is DE10 standard board? So DE10 standard development kit provides a robust hardware design platform centered around the Intel System on Chip or SoC FPGA. This platform combines cutting-edge dual-core Cortex-A9 embedded cores with leading programmable logic, offering unparalleled design flexibility. Users can harness the benefits of extensive reconfigurability alongside a high-performance, energy-efficient processor system. The SoC from Altera integrates an ARM-based hard processor system, or short is HPS, comprising a processor peripherals and memory interfaces seamlessly connected to the FPGA fabric through a high bandwidth interconnect backbone. The DE10 standard development board features hardware components such as high-speed DDR3 memory, video and audio capabilities, Ethernet networking, and more. And so let's just move on to my platform designers for my designs. So yeah, this is, I think the picture is a little bit blurry, but this is the CLK NIOS 2 Gen 2 on-chip memory, SDRAM GT-AG UART 0 and timer 0, hex, LEDs, and some more. I will put some explanation on the other slides. Okay, so here. So the first thing I use is CLK0. What is it used for? It acts as a clock source or clock generation components, furnishes the system-wide clock signal, essential for synchronizing and timing the operations of various components within the system. And then for NIOS 2 Gen 2 0, the NIOS 2 processor core, a customizable RISC, reduced instruction set computing processor developed by the Altera, which is now is a part of the Intel and functions as the CPU for your embedded system. And I also use on-chip memory to 0. The on-chip memory, or we just use call it RAM, component furnish a swift, low latency memory space for storing data and instructions utilized by the NIOS 2 processors. And then we have SDRAM, external synchronous dynamic random access memory. It provides an extra and expanded memory space external for the FPGA, which is commonly employed for storing larger datasets or codes. And next we have GTAG UART 0. It's the Joint Task Action Group Universal Asynchronous Receiver Transmitter. A communication component facilitates communication between the FPGA system and external devices or software via the JTAG interface, commonly employed for debugging and serial communication. So for our software, we use the Quartus Prime Lite. And then we have timer 0, timer 1, and timer 2. This timer's component generates a time delays or periodic signals serving a purpose in time-dependent operations or establishing time intervals within the embedded system. And then next, I use hex, the 7-segment display, we all know. Component functions as a visual output, presenting numerical values or character on 7-segment displays within the system. And then next we have the LEDs, the light emitting diode. Output component serves as a visual indicator, allowing for the control of LEDs to represent specific system states or conditions within the embedded system. And then next we have the keys. This input components represents push button or keys. It's designed to capture users' inputs. These keys can be utilized for user interaction or as a triggers for specific actions within the system. And then we have PLLO, the phase lock loop. Is a component is employed to generate stable clock signals with control frequencies and is frequently used to create multiple clock domains within the FPGA. I also use switches. The switch input component in the DE10 standard board captures input from physical switches on the board, which is also similar to keys, But these switches can be employed for the user interaction or control specific aspects of the system. So the switch is just, we can move it to up or down to activate or not activate it. Meanwhile, the key is just a push button. And we also have control. The control or system management components is designed to oversee and regulate various aspects of the embedded system, encompassing tasks such as overall system configuration and control signal management. And then next we're going to my NIAS2 code for this embedded system design. And this is the overall looks of my NIAS2 codes, and then I will explain them one by one. So the first, we have this first part, which is including the system.h on the void mains and then unsigned. Okay, so the first include is the code incorporates two header files, system H, custom header file, and the studio H. And the standard input or output header file, the latter is employed for the print function. And then next we have this going to the void main. The first is the volatile unsigned. It is used to memory map register are defined in these lines as pointers to volatile unsigned integers, pointing to specific memory locations. So we have to address our pin address or base address for it, for the system to work or the codes to work. And then these memory locations are linked to hardware registers within the embedded system. And then next I have this unsigned. There is so many variables. I use I, control J, K, A, B, C, D, and S. These variable declarations are present in these lines to introduce several unsigned integer variables that will be utilized in the subsequent code. And then next we have this next code. These J switches and control. This is are to retrieve the value from the memory map registers, which is, we can call it the switches and the control from the hardware, and then storing them in the variable of J and control respectively. And then this is my first code. If control 1, this is, I put it on the switch 8. Yeah, I put it on switch 8, which is used to count the progressively from the number of switches we put it up to counting down to 1. And then this is the use slip is used to pause the delay the program executions for 0.5 seconds. And then next we have this else if control 2. This is, I think I put it on switch 9. Yeah, I put it on switch 9 is on and the switch 8 is off. For this program, I just, when I press the key 0, it will show 1950. But if I put another switch up, it will start counting from 1950 to the number of switch that I assigned. So if I like switch for the switch 2, which is the value is 2, it will show 1952. And then we have control 3. If both of the switch 8 and switch 9 is on, it will show the FADE 555. I want to show something in other words, but it cannot because the maximal alphabetic, yeah, a maximal alphabetic hex is only until F. And my plan is to make my own name, but yeah, it cannot because the maximum hex is 16 and it will show another carrier. And then what happens if I put the switch 8 and switch 9 to 0 or we don't do anything? It will just show ABC 1, 2, 3 and the LED is still blinking. So let's just go to video demonstration. I will explain it. This is my code inside the Corpus Prime line. And this is switch 8 and switch 9 is not on. And I just press key 0, it still shows hello ISU IPAI, which is I program it. And then when I press up the switch 9, it will show 1950. And you see in this video, I'm trying to make some number. Yeah, I'm trying to make 2023 as this year of this recording. And then yeah, I'm trying another switch and it still go back to 1950. And then this is, I switch to switch 8 and you see it starts counting down to 1. And yeah, it's still 0. And then for this one, control C is all the switch 8 and switch 9 is on and it shows FADESS 55 I mean, and then it just shows from this is me trying to another, and see I'm trying, and then this I'm trying to put on switch A, and as you can see it starts counting down to 1. Yeah, it starts counting down to 1. Okay, and then what happens if I have both of them on? It shows FAD55. Yeah, and then we can see the LED starts jumping, and it's also showing on the screen that to count from 0 to 24. Yeah, that's it. And what application that we can use for this embedded system? I'm thinking of industrial automation, medical device, and Internet of Things. So embedded system like an Intel FPGA DE10 standard board in industry can revolutionize automation. With the real-time processing, it efficiently monitors and controls the machinery, enhancing the operational efficiency and streamlining manufacturing process. And then from medical device, it's the embedded systems like this standard board are crucial in healthcare to be sure, and particularly for real-time monitoring devices too. Its reliability makes it well suited for patient monitoring system, diagnostic, and portable medical device. This seamless integration enhance device performance, contributing to improve patient care in diverse medical settings. Meanwhile, for this booming now on this 2023, it's the Internet of Things or IoT. With the growing prominence of IoT in this world now, the embedded system have become integral to connect and control the smart devices. Meanwhile, and the DE10 standard board can be utilized to create IoT solutions, facilitating communication between devices, collecting data, and enabling intelligent decision making. Yep, I think that's all from my presentations. Thank you for listening.